Hello everyone. Today we're going to have a look at question 10 of the November 2022 question paper for mathematics grade 12. The statement reads as follows. We are given three events, A, B, and C. The probabilities of these events or any combination of them recurring is given with this Venn diagram. So as we see here, there's A, B, and C, and we're given all probabilities of those events occurring except X and Y. So the first question, the statement reads as follows. If it is given that the probability that at least one of the events will occur is 0.893, calculate the following. So they are saying that the probability that at least, so probability of at least one is equal to 0.893. All right. So probability of at least one of the events occurring is 0.893. So before we dive into the actual questions, I would like to explain what that means. When we say at least, we mean one of them can occur, or two, or three, or even 11 of them, but there are three events there. So they are saying that the probability that at least A can happen is 0.83, or at least B can happen, C, or any of them happening at the same time, or A and B, C and B, or A and C happening is 0.893. So this basically tells us all the probabilities that are in these cycles of the Venn diagram. So what does that mean? Let's go to the first question. Y, so must calculate the value of Y, the probability that none of the events will occur. So like I was saying previously, when we say at least one of the events occurring, it means that we are considering all of them, all possible combinations, but we are not considering the fact or the event when none of them is occurring. It must be at least one. So this question is asking us, if we are given that at least one event occurring is 0.893, what is the probability that at least two? So none is occurring. So we are negating the statement. We are saying what is happening if this does not occur. And that speaks to Y. So we should all know the general rules of a Venn diagram. If we are to add all probabilities within the Venn diagram, so if we look at this box, we call it a sample space. It has different events. This is also an event. A is also an event, and so on. This is the event that none of these occur, and these are the events that, let's say, A occurs, C, B, and so on occurs. So all of these probabilities should add up to 1. I repeat that. All of the probabilities within this sample space should add up to 1. So if the probability that at least one of these events occurring is 0.893, it means that if we're to add Y, so 10.1.1a, if we're to add Y plus the probability at least one occurring, they should all give us 1. I repeat, at least one is considering any combination of these events. Y is saying that none of these events occurring, so we're in this outside of the cycles, but within the same sample space. So to find the value of Y, we simply take the probability of at least one, we take it that side, so we have Y equals to 1 minus 0.893. And the answer is The answer is 0.107. 0.107 is in 3 decimal places. We can leave it like that, but the instructions at the first page or the second say that we have to write the answers into decimal places. But for this case, we'll just leave it at these 3 decimal places. The reason of these videos, or just the underlying goal, is so that you understand the methodology in terms of instructions and everything else. You can abide by whatever is written for the specific paper, but for now, hopefully you got the method. So we are going to have to look at the next question, question B, 10.1.1 B. 10.1.1 B. It reads as follows. Let's calculate the value of X, the probability that all 3 events will occur. So I would just like to explain something here. When they say all 3 events happen, they mean that at the same time A, B, and C are happening. Y is just a probability, it's not an event. We have 3 events in here. So the probability that all of them occur at the same time is going to be this one. But what are the others? What is this probability? What is this one? And so on. So 0.05. 0.05 is the probability that A only occurs. If you look at these numbers, 0.15x and 0.1, they share, these ones share C, and these ones share B, and so on. So how do we say 0.05? So this is the probability that A only, so only A happens. And then 0.15, this is the event that A and C only happen. So at the same time, A and C, they happen. That's the probability. Now, when we say probability that all events happen at the same time, then we speak of X. Now, how do we solve that? If I go back to the first statement, that the probability that at least one of these events occurring is 0.893. How do they figure that out? They are saying also they added all these probabilities here, 0.05, this and this, except Y. So to find X, it means when we add everything in here, including X, we should go to that value of 0.893, because that's the probability that at least one of the events occur. So let's do that. So if we add X, we add it to all the values in here. So 0.05, 0.15 plus 0.05 plus 0.2 plus 0.1 plus 0.183 should all give us 0.893. So if you add all of those, so the answer is X plus 0.733, and this should equal to 0.893. So if you take this to the other side, X will be 0.893 separated by 0.733, and this gives us 0.16. So we already know that the value of Y, so I'm just going to write this here, Y is 0.107 and X is 0.16. So we're going to move over to the next question now. The next question is 10.1.2. and it reads as follows. Determine the probability that at least two of the events will take place. Let's go back to the definition of at least. So there's a difference, there's two words in here, there's at least and then there's at most. So when we say at least, we are talking of the minimum. So we can include anything above the minimum. When we talk of at most, we are saying this is the maximum. Talk of anything below that, but not more than that. So when they say the probability that at least two of the events can happen, we can consider when two events occur, or when three events occur, or in 5 or 8. But in this case, we only have 3 events. So when we look at the probability that at least two of the events will occur, first thing, this one is the event that is the probability that A and C occur. This is the probability that A and B occur, as well as this one, B and C occurring. But what about this one? This is the probability that all of the events occur. Does this fall within at least 2 happening? And yes, so we need to also consider X. So the probability that at least 2 is equal to the sum this, and this one, because the 3 events are happening there, and this forms part of at least 2 events. So that's going to be 0.15, 0.2, 0.1 plus X, which is 0.16. And this all equals to 0.61. That's the answer, 0.61. Now we're going to look at 10.1.3. Then 10.1.3 reads as follows. Are the events B and C independent? Please justify your answer. Okay, so which one is event B and C? This is event B and C. They're asking if they are independent, and we must justify why we say so. So the most famous question is, what are independent events, or what constitutes independent events? So if you can recap on that, we are going to go back to the first principles. Independent events, or the rule that constitutes independent events. If we were to look at that event, so B and C, if we were to look at P, the probability that both B and C will occur, the rule is that if we look at when B and C occur, this should be the same as when probability of A multiplied by the probability of C. Sorry. So what the rule that constitutes probability of B and C is, or the rule that constitutes independent events, let's say for B and C. So B and C, so probability of B and C should be equal to the product of the 2 probabilities, so probability of B and C. If these are not equal, then the events are not independent. Alright, so let's dive into what these mean in terms of our Venn diagram. So when we look at probability of B and C, I said to you, when we talk of, so this is the same of as, so probability that at least B and C happen. So where or which cases B and C occur? If we look here, B and C occur at the same time here. But is that the only time? So B and C occur there. But isn't B and C occurring also here? Yes, this is the probability that A, B, and C occur, but isn't B and C also occurring in there? So the point where B and C occur is this one and this one, because we see the events B there and C, and here we see the events A and B and C. So A and B and C. So B and C is still part of those events. So what is that? The value. So we add this and this. So that is going to be 0.2, which is B and C in there. We add it to this one. And what is the answer for that one? It's 0.16. And this gives us 0.36. So that is the probability of B and C. Now let's look at the probability of B times the probability of C. So how do we look at probability of B? Probability of B is the probability that the event B occurs. It doesn't say that the event B only, because if it was only, we'll just look at this number and not consider these ones in here. But we are now talking about the probability that B happens. And B can happen here, B can happen here, and here, and here. So we need to consider all those probabilities. So that means that we need to look at probability of B, and probability of B is equal to 0.83, 0.183 plus 0.2 plus x, which is 0.16 plus 0.1, and this all gives us 0.643. That's the probability of B. What about the probability of C? Probability of C is equal to, so probability of C is this event, this one, and that one. So we look at 0.15 plus 0.05 plus 0.2 plus 0.16, and this equals to 0.56. So let's check now. If we multiply B, probability of B and probability of C, what is the answer? So now probability of B multiplied by probability of C is equal to 0.643 multiplied by 0.56, and the answer is 0.36. Now do you see that probability of B multiplied by probability of C is 0.36, and also the probability of B and C equals to 0.36. Therefore, these events satisfy this equation I put here, and they are indeed independent. So that's your answer. These events are independent. Independent. They are independent because probability of B and C is equal to the probability of B multiplied by probability of C. Alright, let's move over to the next question. Going to erase everything. Alright, let's go to question number 10.2.1. Firstly, the statement reads as follows. A 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. The digits may not repeat. Okay, so there are many requirements in there. 4 requirements. there's 4, the code must be 4 digits. It must be even numbered. It must not have 0 or 1, and also the digits or the numbers in the code must not repeat. Okay. Now the first question is asking us how many passable 4-digit combinations are there to open the lock. All right. So we have 10.2.1. We have a 4-digit code in here. 4. Hopefully you can see. We are saying that we cannot use, so in digits we have 10 digits starting from 0 to 9. 0 to 9. And we cannot use 0. We cannot use 0 or 1. So 0 to 9, but we cannot use 0 and 1. So we're left with how many digits? We're left with 2 to 9. Those are the numbers that we can use for the code. So how many numbers are there? 2, 3, 4, up to 9. These are 8 numbers. 8 numbers. All right. So when we look at combinations, so that's the first requirement. I wanna say we have 8 numbers available. Okay. Another constraint is that this must be even. What is an even number? An even number is a number that is divisible by 2. I'm going to repeat that. An even number, if we say we have the number equals to 2k, where k is the element of integers. So it's the element of integers. So k is an element of integers, and we have the formula n equals to 2 times k. So if the number n is divisible by 2, then that number is an even number. And we see that here, if we divide by 2, we are going to be left with k, and therefore n is the even number. But this can be a little bit confusing. So instead of that definition, I'm going to give you an easier one. 2 is an even number. It follows the same equation. 4 is an even number. 6, 8. So within within the 2 to 9 digits, we have in here 2, 4, 6, 8. Those are even numbers. Those are the numbers we can use since we cannot put in 1 or 0. So these are the even numbers that are available. So if we can make sure that our number ends with an even number, therefore the whole of the others will be even. I'm going to make an example. Let's say 12. 12 is an even number because it ends with 2. So 12, let's look at 23. Let's look at 26. If you look at this number ends with an even number because it falls within those digits in there. What about this one? This ends with a 3, and 3 doesn't fall part of even numbers. What about 26? This ends with an even number, which is within those numbers that I put in here. So will 12 be an even number? Yes, because if you divide 12 by 2, we are going to get 6. But what about 23? So 23, we're going to get 11.5. What about 26? 26, we're going to get 13. So you see that there is a remainder in this one, and there are no remainders on the other one. So I want you to understand that if we have a number, any number that ends with these digits in here, we can also include 0, but for this case we're not allowed to put in 0. So if any number ends with the 2, 4, 6, or 8, that number is an even number. And I made an example with simple numbers here, 12, 23, and 26. Please keep this rule wherever you go because it's going to come in handy. It's a very easy way to understand even numbers. There are more complex ways or general understandings that are out there, but I think this one will get you going. So if we have a number that ends with an even number, so within 2, 4, 6, 8, then that number is an even number. And keep note, I'm not including 0 because for our case in here, we are not supposed to put in a 0. But for your homework, please go and investigate, is 0 an even number or an odd number? Is 0 an even number or an odd number? Please have a look at that. Alright, so we know that here we can only put in 2, 4, 6, or 8 for this one because we want to make this an even number. So when we start to restrict, we're going to start to say, okay, no, I'm going to just remove everything now. So when we answer the question, they are saying how many possible 4-digit numbers that can be formed in this code. And it must be even numbered as well as the digits must not repeat. The very first requirement is that it must not contain 0 or 1. Hence why we have 8 numbers that are available. So if we look here, we can only choose from 4 numbers there. So for this one, we can only select from 4 numbers. We know that. It can either be 2, 4, or 6, or 8. But now let's consider what different combinations we can have if we start with a 2, or 4, or 6, or 8 in that position. So I'm going to, please leave questions in the comment section below if you at any point don't understand what I'm doing. So let's look at a case where we have a number that ends with 2. We know that is an even number. So if we have a number that ends with 2, we'll look at end with 2, ends with 4, and 6, and then 8. So if we end with 2, so let me just make it, doesn't have to be this long. So if we end with 2, we are going to have, so from these 4-digit numbers in here, we are going to have a selection of only 1 here. So we can only select 2. So now from 2 to 9, we've already taken out 2. So we have only 7 numbers that are available to choose from now instead of the 8 numbers. And remember, that's because we can't repeat numbers. So if we start with a 2, if we have a 2 here at the end, then we can never have a 2 at any point in here. Alright. So if we choose 2, then it means that we only have 7 numbers to choose from. So at this point, we can choose from all of the 7 numbers, but when we choose them, we are going to select one value. And when we select one value, it means that here, we are no longer going to have 7 that are available. Instead, we are going to have 6 because we have chosen a number in there. So here we'll have 6 numbers to choose from for this block. When we've chosen here, we take 1. What will be the number that, how many numbers can we choose from on that one? You can pause this video and just think about it. So if we've taken 1 from the 6, then it means we can have 5 numbers available here. So the possible combinations that we can have, for instance, we can choose, let's say 5 in here, then it means 5 is not available here. But what happens if we choose 3? So we can choose from 7 numbers, but the next block we can't choose whatever number we've selected before. So we have 7 times 6 times 5 times 1 possible combinations in here just for this block, and this is equal to that's equal to 210 choices. So I'm going to do the same thing for, so this is when we start with 2. What happens if we start with 4? What happens if we start with 6 or 8? So same thing is going to happen. We're going to have 4 blocks in here. And we are going to start with 4 here. 4. So we can only choose one value there, that is 4. 4. So it means here we'll have the same thing here. We'll have 7 values available. We'll have 6 available in here and 5. So we have a 210. We can already see that this is going to be the same thing. So it's going to be 210, 210. So what we do as the final is we add all those different combinations. And that is going to be 210 multiplied by 4, which is equal to 840 combinations. I hope you understood that explanation. Please leave questions in the comment section below to understand. This is a very tricky section, so please make sure that you understand. We are going to move over to the next question now. Okay. The next question is asking us to calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5000, so 5000, and the third digit is 2. Okay, so the code is greater than 5000. Code greater than 5000, and the third digit is now 2. So out of the requirements that we had before, which is even number, no 0 or 1, and the digits must not be repeated, we are now told that we need to be greater than 5000, and also the third digit must be a 2. So what that means is that we now have a restriction here on the third one. We also have a restriction, a further restriction on the first one. Now, as I said, so same thing that is going to happen now. We still need to make sure that this number is an even number. So if it is an even number, I told you that it can only have 2, 4, 6, or 8. We cannot select anything in between there because it's going to make it an odd number. So same thing. We're going to have a case. We're going to have a case whereby we end with a 2, a 4, a 6, or 8. Now please correct me. Do you see that I included 2 in here, and I said 2 can be part of these numbers? But what is the requirement that is added in there? They are saying that this number here can only be a 2. The third digit can only be a 2, which means that we can no longer have 2 available as a selection of the numbers that are going to make this an even number. So we need to remove 2 from there. Now we're going to have at the end 4, 6, or 8. So if we go for 4, we're going to divide the number into 4 blocks, like we remember. So if we choose 4, we already have one combination there. If we choose, here we're forced that this should be 2. So we already have one option in there. So we have taken out already, so from the 8 numbers, we've already taken about 2 numbers. So now we're left with 6 numbers. So let me just make that clear. So we have 2, 3, 4, up to 9. So we have taken 2, we have also taken 4. We are now left with 3, 5, 6, 7, 8, and 9. So because we're saying here we can only have a 2, here we can only have a 4. So now if we go back at this position, how many possible numbers can we fit in there? We have 1, 2, 3, 4, 5, and 6 numbers. But another requirement is that this number should be greater than 5000. So 5,000. Greater, is it greater? Yeah, so it should be greater than 5,000, which means that our number cannot start with anything that is below 4. So the first digit, to make it 5,000 or 5,001, so 5,001 is a number that is greater than 5,000. And what is important to note is that it starts with a 5. It can't be a 4, 3, because that will make it less than 5,000. So already here we cannot select 3. So we have how many numbers available? 5, 6, 7, 8, and 9. So we have 5 options. We have 5 options in here. And let's say we take one option in there. So if we take one, we are now going to be left with, okay, so if we look at the second part now, we can choose any number in there, but it cannot be 0, cannot be 1. And also, it cannot be a 2, it also cannot be a 4, and it cannot be the number that we chose in here. So already, we had how many numbers here? 1, 2, 3, 4, 5, 6. So 6 numbers, and we said that here we can only choose 5 because we are excluding 3. So now, after choosing from the 5 numbers, we'll be left with 4 numbers, and we'll still have that 3. So how many numbers do we now have to choose in this block? So we'll have the 3 that we didn't choose, we are not allowed to choose on the first block. And then we'll have the 4 remaining numbers after we've chosen 1 from the 5. So here we'll have 5 numbers to select from. Let me repeat that. In here, we cannot choose anything below 5. So we have 5 options of numbers to select from. And once we take out 1, from those numbers, we are going to have 4 numbers left, whatever. So if we choose 9, or we choose 6 or 7, but we are going to be left with 1. And we are therefore going to have 4 numbers plus that 3 we left out. That's why we have 5 options in there. What happens if we select 6? If we select 6, we start with that 2 here. So this cannot change. It should always be a 2. And now we start with the 6 in there. So how do we choose now the first block? So I said to you, after choosing in here, we can only now have 3. So apart from, so opposite from what we had before, we can now choose from 3, 4, 5, 7. We skip 6, 8, and 9. So we cannot choose 6 because we have chosen 6 as the end block. We cannot repeat 6. So we have how many numbers to choose from? So 1, 2, 3, 4, 5, 6. But we cannot choose 3 and 4. So we can only select from 4 options. We can only select from 4 options for this number. So we can only select 4 options. What about this one now? So after selecting from the 4 options, we'll be left with 3 options. Therefore, for this block, we are going to have these 2 plus 3 options. So we're going to have 5 options to choose from. For 8, so for 8, we always have to fix this one to 2. Then at the end there we end with an 8. And from these 2 blocks in there, we then change this requirement and say we now have 3, 4, 5, 6, 7, we skip 8, we put 9. So we have still 6 options, and we've already taken 8. So it was 7, we've taken 8. And now for this block, how many numbers can we choose? We cannot choose 3, we cannot choose 4. We still have 4 options that are left. Now after that 4 options, we will take one number in here, which means we'll have 3 options left. So from that 3 options, from those 3 options, we can add with these 2 options in here, 2 plus 3 options, which means we're going to have a 5. So now the final answer, how many numbers we can choose from that are above 5,000. There must be the 4-digit code, and they must also be even. So we'll have 5 multiplied by 5, that's 1 times 1. 4 times 5 times 1 times 1. 4 times 5 times 1 times 1. So in here we have 25. In here we have 20. 20. So we have 65 possible numbers that are above 5,000 and they are even. But the question is saying that we must calculate the probability that we can select one of those numbers. Or on the first attempt, we can have the right code. So we have 65 options to select from that is above 5,000 and is still even. But how many numbers are there? How many possible combinations are there? Which then goes to the first question. So if we talk of probability should have the total and the possible. So the total combinations is 840, as we have calculated previously. Now, what are the possible options that we have for this question? Options that we select something that is above 5,000. It's even, it doesn't repeat any number, doesn't contain a 0 or 1, which is exactly what we calculated here. So we have 65 over 840, and that is our answer. I hope you managed to follow up, and please leave questions at the comment section below. It is very important to understand this section, and like I said, once you get the gist of it, you'll never forget anything about probability. It takes practice, but with us, you are going to definitely solve any probability question that comes towards you. So thank you.